Good afternoon. I'm Yongho, Senior Deputy Director of the Ministry of Environment. Thank you for inviting to the international conference to discuss resource circulation strategy for carbon neutrality. I would like to also thanks to the Korea Society of Waste Management and Professor Jang Yong-Chul of Chungnam National University. Today, I will give a presentation on the Korea circular economy towards a carbon neutral society based on the K Circular Economy Action Plan. Table of contents for presentation. First, background of the policy. Second, the basic direction. And finally, the details of the specific circular economy implementation action plan. Its background. In the past, the economic paradigm since the Industrial Revolution has been a linear economy. Each country has led economic growth based on mass production and consumption, thereby creating jobs and revitalizing the economy. However, in this linear economic structure, the economy circulated, but the material produced did not circulate. Mass production and mass consumption inevitably caused resource depletion and a large amount of waste. It's like a 100-meter sprint without a long-term perspective. Now, not just for ourselves, but for future generations, we must shift from 100-meter sprints to long marathons. For this, we may have to sacrifice immediate convenience. However, the transition to a circular economy has become an irreversible trend due to frequent natural disasters, climate change, and soil contaminated with waste. The world is now taking action to steer away from the linear economy that has been a prevailing model since the Industrial Revolution. Now, we are aiming to move towards a circular economy where wastes are minimized and resources are circulated throughout the entire economic cycle. Efforts to transition to a circular economy are spreading around the world. Based on Europe's Zero Waste Program for a Circular Economy and the Europe New Circular Economy Implementation Plan for 2020 was announced. In addition, the Seoul Declaration adopted at the 2021 People's Seoul Summit Korea hosted also reminds us that the transition to zero waste society is a critical path we should take to achieve carbon neutrality goal. The government of the Republic of Korea is doing its best to accelerate its transition to a circular and carbon neutral economy. Last September, Korea became the 14th country to have 2050 carbon neutrality vision, and its implementation mechanism in law with the enactment of its Carbon Neutrality Act. Shortly after, we established the Circular Economy Action Plan for robust implementation. And the basic direction. The vision for 2050 to be achieved through the transition to a circular economy is as follows. Zero waste, realize carbon neutrality by 2050, and complete transition to a circular economy society. By minimizing the consumption of natural resources and maximizing the utilization of circular resources, we maximizing the efficiency compared to the input of resources, thereby minimizing the new generation waste. As a specific implementation goal, we plan to raise the waste benefit rate from the current 6.1% to 1% by 2030 and eliminated waste from landfills by 2050. In addition, the amount of greenhouse gas emissions in the waste sector will be reduced from 1.7 million tons in 2018 to 4.4 million tons in 2050. Finally, the recycling rate of resources will also increase from 86% in 2019 to 99% by 2050. For the transition to a circular economy, Korea has prepared detailed implementation tests for each phase, subject, and item. First, we plan to strengthen the management of the entire resource circulation process. Korea plans to expand the use of raw materials that help producers recycle resources, manufacture products so that they can be easily recycled from the beginning of production, and encourage consumers to increase consumption of eco-friendly products. In addition, we support the revitalization of reuse, recycle, and remanufacturing sectors. Second, Korea prepares to implement a circular economy for each entity. Korea will guarantee consumers' rights so that they can reuse and reuse products and encourage business to conduct eco-friendly management. In addition, local governments must establish a circular economy system that matches the characteristics of each city. Third, we will establish a circulation system for each item. Korea will expand and manage the designation of valuable items as resources among waste. In particular, we plan to focus on management so that the circular use of the 7 items highlighted in the European Circular Economy Implementation Plan can be expanded. Based on this, Korea plans to prepare a circular economy scenario as part of the 2050 carbon neutrality scenarios and achieve economic value creation and carbon emission reductions. For your information, the circular economy could generate 4.5 trillion of additional economic output and is estimated to reduce 48% of global carbon emission and 37% of energy consumption in EU by 2030. And the next is Circular Economy Action Plan. The first step is to use raw material considering resource circulation. Companies will develop and commercialize innovative materials that can replace plastics, such as aerogel and bioplastics, and the government will support research and development in these areas. In addition, Korea will increase the use of recycled materials at production stage. Next is the introduction of a circular manufacturing process. From the moment the product is designed, we plan to use less resources and make it easier to recycle. The government will minimize the amount of plastic raw material input and minimize unnecessary packaging space in the future so that eco-design can be established in products. In addition, Korea will expand smart green factories and industrial complexes. Furthermore, the use of label-free PET bottle and paper-only packaging will gradually expand for reducing resource use and strengthening circulation availability. For example, 22 bottled water companies in Korea signed an MOU with the Ministry of Environment in March of last year. And based on this, they are launching label-free PET bottles. And next is eco-friendly consumption. Store without disposable cups, zero waste store, and refill modes should be the items everyone could see anywhere in everyone's daily life. We will continue to operate programs to create an enabling environment where these items are widely used. And recycled products will be more purchased in the public sector. When it comes to consumption, the government encourages consumers and businesses to reuse their products. The government is planning to improve regulatory methods so that companies can expand the remanufacturing of electronic products and parts, and expand the installation of upcycle centers in the whole country. Reuse or remanufacturing is a kind of recycling, and it's a kind of efficient recycling method that can maintain the original characteristics of the product, rather than recycling the product through process such as crushing and washing. The government ensures that the waste generated after use can be easily recovered and recycled. The government supports the technological development of related companies so that they can return urban waste back to resources such as recycled refined oil. In addition, Korea plans to establish in advanced facilities and systems that can recycle waste-based batteries for electric vehicle, and waste solar panels, which are expected to occur a lot in the future. Through this, Korea will eliminate blind spots in recycling and ensure that the generated waste can be properly returned to resources. The government also strengthens consumer rights related to circular use. The government improved eco-labeling such as carbon footprint and environmental labeling. In addition, for enhancing the right of repairs, we will launch a legislation process guaranteed to consumers the right of repairs. This will be linked to product life cycle assurance, software upgrades, and parts for repair. The government also provides institutional support to the problems that environmental companies are experiencing due to various regulations. It is a regulatory sandbox in the circular economy sector. Throughout this, government plans to enable companies in the environmental sector to quickly check regulations relate to the circular economy, obtain regulatory inspection for verification, and obtain temporary permits. Local governments that are responsible for disposing of domestic waste should strengthen the recycling system for each city. The government plans to legislate the principle that local governments dispose of local waste within the region and will also minimize incineration and landfilling. In addition, local government will promote circular economy projects according to regional characteristics, and the government will provide support when local government builds smart green cities combined with IT technologies. Thank you for listening. And the circular economy goes beyond simply protecting the environment and will become a new growth engine for the future. As the transition to a circular economy has become an essential task, not an option, the Ministry of Environment will do its best to establish a circular economy in Korea. Thank you.
Thank you. Thank you, Mr. Chair. Good afternoon from Japan. My name is Koji Yamada, Management Division, Ministry of the Environment, Japan. I am pleased to participate in the important and timely meeting. In this presentation, we would like to share the formulation of the net zero scenarios by 2050.
Okay.
In the material cycles and waste sector. In 2020, Japanese Prime Minister declared that Japan would aim to reduce greenhouse gases emission to net zero by 2050. In the material cycle and waste sector, it's essential to urgently consider emission reduction measures to achieve net zero greenhouse gas emission by 2050. So the Ministry of the Environment has formulated a scenario for achieving the goal by setting multiple scenarios according the strengths the countermeasures. So today we would like to share the scenarios. So okay. I will invite Ms. Yamamoto to introduce the concrete contents of the scenarios. Please, Ms. Yamamoto.
Thank you very much.
Thank you so much. Thank you so much. We will make a presentation on the scenarios as Mr. Yamada has mentioned. I'm Masato Yamamoto, and in the same room, we will be presenting the slides. We are from Pacific Consultants, and we have been conducting the study for the Ministry of Environment of Japan. This is the context, background objectives, role of the material cycles and waste management sector for achieving net zero, 3 priority areas for action and basic approach, 4 scenarios for analysis, 5 measures in priority areas, 6 results, 7 implications, 8 next steps. For background and objectives, Mr. Yamada has already said, so I will skip the slide. On the left is the Japan's total GHG emissions from fiscal year 2019. That's 1.2 billion tons CO2, and waste sector is 3.3%, which is 14 million tons CO2. On the right, you can see the waste sector's GHG emissions, and you can see that about 80% is CO2 emissions. And also from the bar chart on the bottom, you can see that incineration make up around 80%. This comes mainly from waste plastic and also waste oil, incineration of waste plastics and waste oil. Next slide. There are two main goals of sector for achieving net zero. The first one is to improve resource productivity based on 3 R's and renewable concept. The material cycles and waste management sector has been helping to reduce GHG emissions and energy consumption through the 3 R's and heat recovery, and has further potential to do so. Secondly, this sector is one of the major sources of non-energy related GHG emissions, so the achievement of net zero emissions in this sector will be crucial for net zero overall in Japan. Thirdly, the potential exists for further reductions in resource and energy consumption by increasing the resource efficiency of durable goods. Fourthly, the 3 R's and renewables concept is part of crucial strategy to achieve carbon neutral society. This includes minimizing incineration and landfill of carbon-containing materials, reducing energy consumption in production process, shifting to the use of biomass-based materials, as well as using renewable energy in waste treatment processes. Lastly, implementation of 3 R's is an important place to start, as biomass procurement involves constraints in terms of sustainability. The second role of the sector is decarbonization of material cycles and waste treatment systems. Firstly, the sector emits waste-derived GHGs, mainly from the incineration energy recovery of fossil-derived waste in the landfill of biomass waste. To reduce these non-energy related GHG emissions, the sector must bolster its 3 R's efforts, opt for low-emission waste treatment methods, and shift toward the use of biomass-based materials for manufacturing. Secondly, the reduction of energy-related CO2 emissions from the waste treatment requires various efforts, including utilizing energy from waste, reducing energy consumption, and shifting to the use of renewable energy in waste treatment processes. Thirdly, for sampling and other reasons, incineration cannot be completely eliminated, so actual GHG emissions from this sector cannot achieve zero. So therefore, fourthly, CCUS becomes important to cancel out the GHG emissions and even achieve negative emissions, since the incineration exhausted gases include biomass-derived CO2. Lastly, it is an urgent matter to devise and present strategies to achieve carbon neutrality in the sector by 2050. Based on these rules and principles, we set 3 strategies and priority areas for achieving net zero emissions in 2050. Based on the 3 R and renewable concept, we set 3 strategies. First, decarbonizing the entire life cycle materials through resource circulation. Second one is develop waste treatment systems contributing to regional decarbonization. The last one is decarbonize waste treatment facilities and vehicles. For the first one, we focused on materials with high non-energy related GHG emissions. For the second strategy, we focused on treatment method with high regional reduction potential. For the last strategy, we'll focus on steady reduction of emissions and efforts to avoid locking in high emission structures. This figure shows the basic approach of the sector toward carbon neutrality in 2050. The vertical axis is GHG emissions, or for the bottom part is reduction of the sector. The GHG emissions from the sector, which is shown navy, this navy part is the GHG emissions of from this sector. This will be reduced through 2R, reduce and reduce. material recycling, chemical recycling, and use of biomass in materials, as well as GHG reduction technologies. If you look at the bottom part, the orange bar, this shows the waste power generation and heat utilization. This will expand for the time being, but this estimated GHG reduction effects will decline with the progress of net zero emission from electricity. So the orange bar it decreases with time. If you look at the blue part, this is the GHG reduction effect in other sectors by recycling. And this box becomes larger in 2030, but disappears in 2050. We vote here. The sector will contribute to decarbonizing other sectors through replacing use of raw materials by recycled materials. However, the materials industry may achieve decarbonization in some other ways. Therefore, we did not include these reduction effects in the scenario analysis. So, as I said before, GHG emission will not be zero in 2050 because of the incineration and sanitary purposes and so forth. CCU has become important here to cancel out the GHG emissions in 2050. These are the scenarios we have set. There are 6 scenarios beside BAU. The first one, BAU scenario, we assume the current measures will remain unchanged until 2050. The next 4 scenarios, we assumed measures according to the priority areas I mentioned, but the strength of the measures are different. It gets more, the strength becomes more if you go down the scenario. And the last 2 scenarios, CCU is considered only in the last 2 scenarios. I will explain about measures assumed in each priority area. For detailed assumptions on intensity of the measures in each scenario, please have a look at later slides attached to this presentation file, which I will not explain now. This shows priority area 1. We assumed measures for waste plastics. The basic concepts are reduce, reuse, separate as much as possible, material recycling and feedstock recycling to minimize incineration and final disposal, and promote bioplastics. The 2 bar charts on the bottom shows the volume of waste plastic by treatment method and the composition of waste plastic on the right for the advanced innovation scenario. You can see that incineration is decreasing with time from the left bar chart, and from the right bar chart, you can see that biomass based plastics is increasing with time of these purple and green ones. For waste oil, we assumed material recycling and biomass conversion. And these 2 pie charts show the current treatment method of waste oil. Left is for waste lubricating oil, and its major treatment method is energy recovery. And on the right is the waste solvent, and the major treatment method, the current method is incineration and energy recovery. We also assumed material recycling and biomaterial conversion for disposable diapers. And for waste paper and synthetic fiber scraps, we assumed material recycling, reduce feedstock recycling. And also we assumed several measures for scrap tires as well. This is for measures in priority area 2. We assumed organic waste management, waste energy utilization, power and heat, and CCUS. The bar chart here shows a composition of newly built incineration facilities from 2031 and beyond. As you can see, the capacities of incineration facilities becomes larger if you go, when you go down the scenarios. And also, methane adoption of methane fermentation become larger as you go down the scenario. This slide shows measures we assumed in priority area 3. For municipal waste treatment facilities and waste collection vehicles, we assume these measures. For incineration, human waste treatment, and other treatment facilities. And we also assume some measures for waste collection vehicles. And at the moment, GHG emissions are large from incineration facilities and human waste treatment facilities and waste collection vehicles. So more measures are assumed in those facilities and vehicles. The slide shows the result of scenario analysis. You can see that this is BAU. This is expanded planning. So the expanded planning scenario isn't good enough in terms of GHG reduction. On the right-hand side, you can see bar charts of the GHG emissions by scenario in 2050. You can see from the scenario with CCU, you can see that at this cancel out this emission and so forth. This slide shows GHG reduction effects for several scenarios. This is historical and expand planning scenario, innovation scenario, and so forth. BAU is just the top line, and this shows how much is reduced from these measures. So you can see that green is waste plastics, so measures for waste plastics has a large potential for reducing GHGs, as well as waste oil and energy-related CO2. And this dark gray shows the reduction of GHG from CCUS. Here are implications overall. The material cycles and waste management sector can reach net zero or even negative emissions by 2050 by deploying CCUS to the maximum extent possible at waste treatment facilities. Secondly, measures based simply on extending existing plans and policies are insufficient, while implementing technological and institutional measures or concerned parties should work together to address the challenge with greater ambition. Thirdly, under the basic objective of reducing GHG emissions as much as possible, material cycles of the sector should implement stronger 2Rs measures and further advance efforts in priority areas. Lastly, the scenarios should be updated based on changes in prospects for the materials and manufacturing industries. Some implications from priority areas. For priority area 1, firstly, for waste plastic, it's important to focus on promotion of material recycling, feedstock recycling, as well as age improvement with raw materials and materials shift to use of biomass plastics. For waste oil, it will be necessary to initiate efforts on material recycling of waste oil, such as lubrication oils and waste solvents, learning from other countries that are on the forefront of such efforts, and so forth. I'll skip the first point. From priority area 2, waste treatment facilities have long service lives once built. So it's crucial and important to encourage the construction of low carbon facilities at early planning stages in order to reduce energy consumption in long run. Secondly, in scenarios to significantly reduce GHG emissions from this sector, the unit value of waste treated is expected to decrease over time due to significant progress in the 3Rs, such as the use of separated waste plastics. So energy balance is expected to improve through the adoption of integrated treatment technologies such as methane fermentation, as well as consolidation of treatment facilities. Implication from priority area 3, regarding electricity used in waste treatment facilities and waste collection transport vehicles, significant GHG emission reduction can be expected in this sector based on the introduction of renewable energy plus CO2 emission factors for electricity towards 0. These are next steps. We have done the first scenario analysis, and from now on, consideration or start thinking about how to implement measures, as well as keep updating the scenarios along with institutional development promotion. Thank you for your attention.
Thank you very much. And do you have another presenter, Mr. Lee, or you okay?
She's okay. Thank you so much.
You're okay. Okay. That's excellent presentations from Japan's efforts toward the carbon neutrality in material cycle and waste management sector. Thank you very much. And now we're gonna move on to the last presenter, the strategy of sustainable solid management in EU toward the carbon neutrality from France. Professor Chungnam Kim, he's a professor at the University of Technology of Troyes. Please go ahead and present. Thank you very much.
Okay, thank you. Good afternoon and good morning here in France. Good afternoon in Asian countries. This is Chungnam Kim in University of Technology of Troyes in France. Firstly, I want to thank to the session chair, Professor Jang, Yong-Chul, and program organizers for giving me this great opportunity. As you can see here, today I want to share and introduce the European project and strategy on waste management and carbon neutrality. For the first part, I want to show some data and statistics about waste and carbon emission in Europe and OECD countries. So, this figure shows the waste data in OECD countries in 2019. The OECD countries generate the waste from 315 kilogram to 809 kilogram of waste per person per year. The OECD countries' average waste amount is about 538 kilogram per person per year. In the OECD countries, the United States was the highest, was the most waste generation country. One American person generate 809 kilogram, and Denmark 781, and New Zealand 727 kilogram waste. instead of those countries, the Eastern Europe countries and also Asian countries, such as Poland, Czechs, and Korea, Japan, generate much less waste, from 315 to 359 kilogram per person. Also, this graph shows the waste generation data from 2000 to 2019 in OECD countries. Some countries' data was increased and decreased during this period, but the average waste generation amount in OECD countries was not big change. From 546 kilogram per person in 2000 and 538 kilogram per person in 2019. If we check the average gross domestic product, GDP, in OECD countries, it was $24,635 per person in 2000. In 2019, it was $46,110 per person. So the GDP was increased about 87%. So waste is stable and GDP was increased. So from this data, we can see the economic and waste decoupling pattern also. Let's see the EU waste data. The average municipal waste per capita in the EU in 2020 was 505 kilogram. It was 506 kilogram in 2005. Like OECD countries, the waste data was not big changed from 2005 to 2020. I think the European also tried to reduce the waste when the GDP was increased from $27,000 to $34,000 in 2020. Also, from here also you can see economic and waste decoupling from EU waste and GDP data. This table and figures show the waste treatment method in EU countries. In 1995, the most waste was treated with landfill method, which was 61% of the total. Incineration was 15%, and material recycling 12%, and composting was just 7% of total. During after 15 years, it was changed significantly. The landfill of waste was decreased from 61% to 23%, while incineration 15% to 27%, material recycling 12% and 30%, was composting 7% to 80% increased. I didn't check the, but I think the other OECD countries have a similar change like this. I saw the Japanese data also is it is a little bit similar data. Also, this graph shows same change graph. Landfill amount was decreased, and incineration and recycling and composting amount of waste was increased. This figure shows global greenhouse gas emission by sector. Global greenhouse gas emission continued to rise at the time when they need to be rapidly falling. To effectively reduce emission, we need to know where they are coming from, which sectors contribute the most, how much we use this understanding to develop effective solutions and mitigation strategies. Here we look at the breakdown, the emission by sector. to prevent severe climate change, we need to rapidly reduce global GHG emission. The world emit around 50 billion tons of GHG emission each year. So from here, energy sector is the most significant contributor, about 73%. And then agriculture and forestry and land use has 18.4% and industry 5.2%. This is the direct industry processes. Here also waste contribute 3.2% in total GHG emission. Where our greenhouse gas come from? This chart shows the breakdown of total greenhouse gas by sector. Here we see the electricity and heat production are the largest contributor of global emissions. This is followed by transport, manufacturing and construction, and agriculture. But this is not the same everywhere. If we look the United States case, for example, transport is much larger contributor than the global average. In Brazil, the majority of emissions come from agriculture and land use change. The EU data also shows very similar percentage, what I showed you before. The energy sector, including the transportation part, the most significant contributor as the previous slide. In 1990 and 2018 is not so big change. The EU moves toward circular economy and carbon neutrality. Many people already know about the European Green Deal to overcome the environmental issues, climate change and global warming. The European Green Deal will transform the EU into a modern, resource efficient and competitive economy, ensuring no net emission of GHG emission by 2050, like Korea and Japan. Before slide. Economic growth decoupled from resource use, no person and no place left behind. The president of the European Commission and also vice president of the European Commission said the European Green Deal is our new growth strategy. It will help us cut emission while creating jobs. Also, we propose a green and inclusive transition to help improve people's well-being and secure a healthy planet for generations to come. With this important message from President and Vice President, the European Green Deal will decarbonize the energy sector, also renovate buildings to help people cut their energy bills and energy use, and support industry to innovate and to become global leaders in the green economy, and roll out cleaner, cheaper, and healthier form to private and public transport. So here also, currently the European industry uses only 12% recycled materials, but by 2050, this percentage will be significantly increased. When I prepared this slide, I checked the European project related to circular economy and carbon neutrality and waste. There were many projects. So I just summarized some important projects here. One project was about textile waste. So they try to recover and recycle textile waste. And another project was about also building materials recycling. So they try to develop tools for circular building, material recovery, recycling, and assessment. And also one project was about renewable energy waste. So this project was about photovoltaic waste. So from photovoltaic waste, they try to recover valuable materials. Also, they want to get benefit for the circularity of the PV industry. And also, this is the also construction waste, also urban waste recycling project. Also, they suggest some new collection method and recycling and method. And also, yeah, here bio-based raw materials and eco-friendly packaging design adapted to these plastic to improve collection and recycling. Also, this project tried to increase recyclability and enable to robust after-use plastic economy. And then also some projects were about bio-waste recycling, and also they try to reduce the impact of waste collection and recycling. Also, if you see France case, so France also introduced national low carbon strategy in 2015. So it outlined the approach to be adopted to reduce greenhouse gas emissions. It set in motion the transition to a sustainable low carbon economy. It facilitates the management of policies for reducing greenhouse gas emission by public decision makers. So up to date, France tried to reduce GHG emission from 552 million tons in 1990, and then 992 million tons in 1913-14. So a little bit decreased. We can see here from this figure. Also, the France has the target carbon neutrality by 2050, net zero emission. So yeah, I want to skip this one. So I want to focus on one slide about waste part in the GHG emission reduction target. So the waste disposal sector currently account about 3% of French national GHG emission. The strategy aims to reduce the sector's emission by 37% by 2030 compared to 2015, and by 66% by 2050. It's not zero, it's 66% by 2050 compared to 2015. So yeah, and so finally, I want to suggest some further studies. So when I prepared this presentation, I checked many projects and many studies. So there were many carbon footprint analysis assessment in waste treatment, recycling and recovery and reuse and management system. So I think we should continue this kind of carbon footprint analysis assessment for specific waste treatment process and more specific recycling process. Also, when the recycled materials are reused for raw material, so this kind of thing should quantify well. Also, many material flow analysis studies were conducted Also, waste flow analysis in waste treatment management system should be conducted. Also, we can focus on more specific waste flow, plastic flow and food waste flow, and specific waste flow study we should continue. Also, conducting this waste flow analysis, so we should also quantify the CO2 emission flows together. Also, I showed some projects. They showed, okay, they developed new recycling process and collection process, but the quantification were very weak. So quantification studies of avoided and saved GHG emissions are required. How much GHG emission are avoided and saved from 1 ton of PET bottle recycling, and when upcycling and downcycling, how much CO2 emissions were saved, avoid. This kind of thing should be more pay attention, and we should quantify each factors. So this kind of carbon footprint factor should be applied for policy and future plan to reduce CO2 emission from energy sectors, waste sector. Also, we need more policies, incentives, and also research funding. So, for example, small medium company, they try to reduce the CO2 emission for their new product and process and system. Also, they reduce some amount of CO2 emission, but there's not many incentives about that. There is the CO2 reduction law symbol and certificate, so that is not enough. So I think we should more things than certification. So we need to continue green and eco image of the company, and we need to promote this kind of aspect for the companies. Yeah. So that's all my presentation, and thank you for your attention. If you have any question, and I want to answer for your question.
Oh, thank you very much. We have excellent presentations from France for the European side, and now we're gonna turn to question and answer sessions. So we have about 25 minutes that we can talk, and if you have any questions on the chatting or Q&A sections, you can put your questions. So let me go ahead and check. You have any comments, questions? You're welcome to the presenters. Let me go ahead and start my questions. I think Professor Kim, you have an excellent the overview of waste management trend and carbon net zero like directions and efforts. As you mentioned on slide 20 and on 19, you suggest some material flow analysis and carbon footprint assessment, and also life cycle concept of products by recycling to evaluate avoided and saved greenhouse gas emissions. So more specifically, I think there are some softwares available to assess avoided or saved greenhouse gases. Example like Shimapro or Gavi but in terms of waste recycling, would you be able to like recommend good life cycle assessment software that we can use? Like I know the United States, there is a US warm model, one of the old and very easy to use model. But do you have any experiences or any recommendation on evaluate avoided or saved greenhouse gas in waste sector or some product,
Yeah, okay, that is a good question. So yeah, there are many carbon footprint calculation software. So OpenLCA, also Gavi and EcoInvent, we can use that. But for me, I think from the EcoInvent data, so we can make our own calculation model. So I said the system boundary and process are all different in different countries and different process systems. So we cannot use directly from other countries factors. So maybe we can make our own calculation model. So I'm doing like that.
Okay.
So sometimes I'm using other software, but I'm usually download EcoInvent data, and then I can get the CO2.
Right. More like a country specific or like a size specific or study specific. You make us some kind of a boundary, system boundary, and input data and output. Right? Yeah. Okay. Okay.
Yeah. So also the waste flow analysis studies. So what I know is that the important thing is where comes from the most CO2 emission in waste flow and waste collection and treatment and recycling. So we should know that first, and then we should try to reduce each process and each stage. So that is important study. Yeah, what I proposed.
And I have another question for the Miss Yamamoto. Is she in? Is she on right now? Oh, Miss Yamamoto? Or Mr. E? Mr.
Yes,
E?
we are here.
Yeah,
Yes.
okay. You have a good and excellent presentation on the waste management and carbon neutrality, but waste plastic issue is one of the key priority area if we really reduce CO2 emissions, right? And also your country heavily depending on waste incineration. So you have a big portion of the combustions for municipal solid waste. But I think this is almost like I've never think about that much on waste oil. Waste oil, and you said like lubricant oils and solvents, but because I understand the first priority is a waste plastic to reduce carbon emissions, but I never think about very heavily on waste oil. So I know you have a very detailed data on waste oil, but your waste oil also kind of you broad like lubricating oil, lubricants, and or like solvent, but it's kind of very broad definition. So would you talk about a little bit detail on why second most or like a very priority item that you select waste oil?
Thank you, Chair. I think it's a very good and important question, but I feel a bit difficult to answer you immediately. So, could you summarize your question? So, let me try. You asked us to explain a bit about the details of the generation of waste oil. No.
Yeah, I mean, I want to know, waste plastic is a
Yeah.
the heavy, largest fraction in municipal solid waste or like solid waste ministry. But I never heavily thought about waste oil, which might not, largest fraction or large contributor to the greenhouse gas emissions in my experience or in my country experiences. So I want to a little bit know about waste oil and what kind of oil we are talking about. I really do not have some specific. Yeah, that one, right? So is it largest like some kind of one of the larger a fraction of greenhouse gas contributions, or so you're talking about 1,000 tons, so about 650,000 tons, and okay, so you have lubricating oil and solvent, okay. And what about greenhouse gas emissions to burn or to combust or process?
The waste oil in
Right.
fiscal 2019 fiscal year,
Right.
from waste oil, it's about 9.7 million tons CO2 from waste oil.
Okay.
And
okay.
It's just over 1/4 of CO2 emissions
Okay.
from incineration.
Okay. So I also need to check in Korea case, and I never thought about some big contribution from waste oil, because in Korea you have lubricating oil, and we usually recycle. That's a lubricating oil by solvent separations and some refinery, and then we reuse it rather than just burning or combust it. So that's why I was kind of a little bit surprised you kind of pick or select the second largest waste item that you want to reduce the greenhouse gas emissions, because usually solvent as well, also solvent and lubricating oil, pretty much they are recycled, commonly recycled, recovered, and refined oil, and just keep recycle in a circular way. But you kind of you incinerate as a energy maybe auxiliary sources maybe. Okay, that's good to know.
I'm Koji from Ministry of the Environment, Japan.
Go ahead.
Can I speak?
Sure. Yeah, you're welcome.
Yes, and thank you, Chair. You are right. In Japan, the industrial oil is go to incineration plant, not recycled. So you say that Korea and European countries with industrial oil to recycle. Yeah, so we have to change the waste oil go to the recycled in the future. So we have to challenge in this area. Thank you.
Yeah, in fact, the lubricating oil is one of the items the extended producer responsibility items in Korea. So when you make lubricant oil for car or automobile, you make sure about 70%, 80% you recycle, and then otherwise they get a penalty and they have to pay some fine. So we have a very long history of lubricating oil, used lubricating oil recycle system under EPR system, and then solvent also usually, we recycle waste solvent by evaporation, distillation techniques, and so rather than just burning it, we usually recover and we use it. Okay, and I think that there are some questions in the Q&A sessions. Miss Madaka, may I know you using what kind of model to predict net zero 250? So
Sure. May I show you the diagrams how to read it, but in Japanese.
Yeah, sure. Go ahead.
But while we try, or Sil try to explain you. Just wait a moment.
Sure.
Okay, this is for municipal waste management of how we calculated GHG emissions. Upper part is non-energy derived GHG version. Okay. If you would see the box with GHG here. Okay.
Sure.
This is the future GHG emissions, the red box. And this is the future GHG emission from energy derived CO2 emissions. And this is from non-energy GHG emission, and that's the bottom part is energy CO2 emissions from energy. The blue boxes shows parameters that we changed according to scenarios. So that these shows the differences according to we changed these parameters according to the strength or intensity of measures. I mentioned the priority measures, and we calculated how do I say GHG emissions from emission of waste ton per day per capita. This is future population, and we calculated future emission of waste for waste management. This is from future population and amount of amount of waste per day per capita. And this is GHG emission factors for municipal waste. And these are like biomass plastic ratio or ratio of landfill to semi-aerobic landfill. Or this is like composition of waste incineration facilities. So we changed these parameters according to scenarios. And can you see? This is to our effect by kinds of waste. And these are kinds of waste. And these are kinds of treatment, material recycling, chemical recycling, energy recovering, and this is position, compost. And this is future
future amount of treatment for each kind of waste and each kind of treatment method.
And for the energy derived CO2 emissions, they calculate from future energy consumption and also future energy emission factor, GHG emission factor by energy sources. And these we are differentiated according for incineration and human waste treatment facilities, existing or new facilities, or by technology or by capacity. So we changed in scenarios, and these are energy factors. I mean consumption, future consumption, future energy consumption of new facility. Like we change by scenario, like how much is it, the efficiency or process or
electricity generation efficiency.
Okay, and how much of electrification, and also for CCUS. Sorry, my explanation isn't good, but we use these parameters and for calculating future GHG emissions.
Okay, thank you very much. And related to the your greenhouse gas reductions, there is some also questions about you're like a net zero scenario. It's a CCUS is one of the also key factor to achieve a net zero society. So one of the audience asked about, would you explain a little bit about current or developing CCUS technology in waste sector? So can you answer that questions?
Well, we have some demonstration plant or pilot study plant already in Japan. I think the most famous one is the incineration plant in Saga City in Kyushu Island, the southern island in Japan. They capture carbon dioxide from the branched flue gas, not all of the flue gas, but part of flue gas. And they utilize carbon dioxide to their agricultural purpose for algae or so some kind of vegetable, green vegetable, to foster the growth of the vegetables.
Okay, in Korea also we do have about 17 million tons of CO2 emissions from waste sector, and so it's about 40% of Japanese emissions amount, and but we do not have any like a CCUS methods to reduce greenhouse gas emission from incineration, but we might look at. But nowadays, CCUS is also one of the like very promising technology in Korea as well, and we kind of pushing toward that directions to CO2 capturing and CO2 storage and CO2 utilizations methods that we are working on many industry, and also we are making a law for CCUS oriented, like industry development, industry like supporting measures, things like that. So we are doing that direction as well, but we do not have right now a net zero analysis for waste sector. We only look at some bio-based bioplastic and more energy recovery and some bioenergy project, but we do not have very specific CCUS reduction methods, unlike Japan. So, okay, and I think it's any other questions from the audience? I do not see here, and we have about 3 minutes.
I have one question to Yamamoto.
Okay, go ahead.
Yeah. So in slide 10, page 10, you showed the graph. So I think I don't know that this is what I understanding from the figure. The plastic waste amount is decreasing. Is it correct? Yeah, here. Page 10, I think. Yeah, here.
This is slide 10, right?
The volume of waste plastic seems like decreasing. Is it correct? I don't know. In the future, I think we are using more plastic, and also we will have more waste plastic, but I don't know. How did you get this graph?
And 8 million ton per year.
Maybe cute.
Action.
Action there.
Can you look up?
Yeah.
Sure.
Can you see the functions for waste plastics?
25% reduction.
Reduction.
Yes.
Yeah. We also have kind of similar predictions, similar policy, like 25% reductions by 2030, and then 2050 we replace all the fossil fuel based plastic with bioplastic in Korea. So
Right.
okay.
Good.
Yeah,
in Starbucks also they changed the plastic cap to paper cap, so
right.
maybe it can be reduced. Thank you. Yeah.
Thank you very much, and I think it's time to close, and we are very happy to have all 3 excellent presenters. One presenter, unfortunately, he had to go on the video presentation, but from France, Professor Kim, thank you for your participations and contribution, especially in the very early morning, 6 o'clock or 7
It's my pleasure.
o'clock in the morning, and also the from Pacific Consultant in Japan, you present quite a good overview of your net zero scenario and analysis and directions in waste sector. Thank you very much, and we have a good discussion as well, and now we close. Thank you very much, and stay safe, and hopefully we wonderfully close the 3 Rings conference within a few hours. Thank you very much. Stay safe.
Thank you so much.
Thank you.
Thank you so much.